Welcome to Chapter 7. This week we're going to talk about the concept of elasticity. Now, I agree probably with everybody when I'm going to take a look at these discussion forum posts. I'm probably going to see a lot of commentary stating that this chapter was really difficult. So if you are having difficulty with the elasticity chapter, please don't be discouraged. This is normal. This material is very difficult. And I'm going to try to walk you through some of the calculations and concepts so that it's a little bit less difficult for you, but please don't be frustrated by the fact that you're feeling challenged because this is very challenging material this week. So, elasticity is the concept of looking at the sensitivity of either the demand curve or the supply curve to changes in price. So we know that as we increase price, we'll increase our quantity supplied. And as we see increases in price on the demand curve, we'll see decreases in quantity demanded. We see decreases in quantity demanded because consumers demand less of a good or service when the price is higher, and suppliers, on the other hand, are incentivized to supply more, ceteris paribus, as they might receive a higher profit. So therefore, we want to look a little bit at how sensitive suppliers are or consumers are to changes in prices for different goods and services. And it's not so much that we want to understand what elasticity looks like for different goods and services in this chapter, but we want to be able to actually do some of the calculations if we're given the data. Okay, so again, we know that at a higher price, less will be demanded of a good or service, but how much less? And we know at a higher price, more will be supplied, but how much more? And so those are the main questions we're going to ask ourselves this week. First, we're going to take a look at our first question dealing with the elasticity of demand. So the elasticity of demand is defined as a percentage change in quantity demanded given a percentage change in price. So this is the percentage change in, sorry, I have this backwards. The percentage change in quantity demanded given a percentage change in price. In an actual formula, so this would be kind of a basic formula, but we want to use the midpoint formula here. Now the midpoint formula is taking the average of the quantities and the average of the prices. So instead of simply saying what is the change in Q2 minus Q1 over Q1, we're actually going to use the average of Q2 and Q1 to get a more precise formula. And we're going to do the same thing for our prices. One way you could simplify this formula is actually to drop the 2's out. Since you have a 2 in the numerator and a 2 in the denominator, you can simplify the formula to be Q2 minus Q1 over Q2 plus Q1 divided by P2 minus P1 over P2 plus P1. If you want to leave the 2's in there, go for it, but that's just a way to help you simplify the formula. Okay, now, so let's do an example of how to calculate elasticity of demand. So here you see we have a demand curve. Let me denote it as such. So we have a certain demand curve, and we have different points along that demand curve, and we only really need 2 points to perform our elasticity calculation. So at a price of $5, we know that 10 units are demanded. But at a price of $3, we see that 12 units are demanded. So more units are demanded at a lower price, which corresponds to the law of demand. So the first thing we want to do is we actually want to assign Q and P values. When we do that, that'll help us keep everything straight when we are calculating our elasticity. So I've done that. Our Q and P values are Q1 is 10, Q2 is 12, so therefore the price that corresponds to that quantity is 5 and 10 and 3 and 12. Okay, so we're going to use our formula to calculate the elasticity of demand. And I've done that here too. Q2, 12 minus Q1 over Q2 plus Q1 divided by 2, all divided by P2 minus P1 over P2 plus P1 divided by 2. So what does this equal? Let's do the math out. 12 minus 10 is 2. 10 plus 12 divided by 2 is 11. So 2 over 11 gives us 0.1818, all divided by 3 minus 5, which is negative 2. 3 plus 5 divided by 2, negative 2 divided by 4. Negative 2 divided by 4 is negative 0.5. So we see that as our price goes from 5 to 3, that our quantity demanded will increase from 10 to 12. The elasticity of demand measured is 0.1818 divided by negative 0.5. Negative 0.3182. Okay, so what does this mean? I think sometimes the elasticity calculation can leave some people in the dust. The calculation is a little bit tricky. Memorizing the formula can be a little bit tricky. And then when you get to interpreting the results, that can be even more tricky. So let's take a look at it. When we say that we have a given change in price causing a change in quantity demand, in this instance, what we have happening is for a 1%, since this is the denominator, increase in price, we see a 0.3182% decrease in quantity demanded. Okay, so for a 1% increase in price, we're only seeing a 0.3% decrease in quantity demanded. Otherwise, for a 1% decrease in price, we see a 0.3182, if you want to be specific, increase in quantity demanded. So is this very elastic, or is it elastic, or is it inelastic, or is it very inelastic? We have some ways of interpreting these results based on what our elasticity coefficient comes out to be. So when we solve this formula for the midpoint elasticity of demand, or we can use it for supply, really this is also called the or our elasticity coefficient. And if it is greater than 1, less than 1, or equal to 1, then we would categorize our results in different ways. We're going to talk about that after we talk about the elasticity of supply, but just remember how to interpret these results. Another way you should probably think about it is that, for example, if the price is going from 5 to 3, the price is falling by almost half, right? Half of 5 being 2.5, but we don't see the same increase in quantity demanded. If we had the same amount, if we had a decrease in price, which was matched by a similar increase in quantity demanded, we would roughly see that for the price to fall by half, 10 should be around 18 or 20 units demanded and not 12. So we don't really see much of an increase in quantity demanded. Again, when we cut our price almost in half being 2.5, so 3 being almost half of 5, we really aren't seeing the same increase in quantity demanded. If we were seeing the same increase in quantity demanded, we would see our increase in quantity demanded be something like 17 or 18, close to 20, not just 2 units of increase. Okay, so the elasticity of supply is similar to the elasticity of demand in that we use the same midpoint formula for calculating it, but we're going to be looking at the supply curve. So the elasticity of supply is the percentage change in quantity supplied given a percentage change in price. Again, we use the same formula, Q2 minus Q1 all over Q2 plus Q1 over P2 minus P1 over P2 plus P1. So I would implore you to try a couple of the elasticity of supply calculations. Instead of thinking about, well, how does a change in price impact the quantity demanded that consumers are demanding? The elasticity of supply is going to say, what does a change in price do to influence suppliers or producers to increase the quantity they supply to the market? Okay, now we're back at the types of elasticity. So we are looking at, once we get our result for our elasticity coefficient as we did here, then we can interpret this result. We know how to interpret it. For a 1% increase in price, we see a 0.3182% decrease in quantity demanded. Now, is this very elastic, inelastic, very inelastic, or unitary elasticity? If our elasticity coefficient is greater than 1, that means that there is a percentage change in quantity demanded that is greater than the percentage change in price. We would call this an elastic situation. If our elasticity coefficient is less than 1, as we had above, we would know that the change in quantity demanded is relatively small compared to the change in price. So the price almost doubled or halved, but we really didn't see the same magnitude of response in quantity demanded. When our elasticity coefficient is equal to 1, that means the percentage change in quantity equals the percentage change in price. So again, this can be either demand or supply, demand or supply, demand or supply, since we're looking at measuring the elasticity of demand and the elasticity of supply. From the perspective of what do these curves look like? So an elastic curve would be relatively flat. We would have a perfectly elastic situation where the demand curve is actually horizontal, okay? Relatively elastic would mean that it's pretty flat. And you can see there that for small changes in price, we're having a large response in quantity demanded. So let me see if I can illustrate this for you. When our demand curve is relatively flat, as I've just drawn, we're going to see a large change in quantity demanded relative to a curve that is relatively steep or inelastic. Okay, so here we're looking at the quantity demanded at one price versus another. So at this price right here, we can see that we have a certain quantity demanded, right? Now if I drop the price just a little bit, we see that the change in quantity demanded, this being our new quantity demanded right here, and the corresponding price is greater than this change in price. So whenever we have a change in quantity demanded that's greater than the change in price, we will have an elastic curve. Now, what happens if I make this curve inelastic? So, if the curve is much steeper in an inelastic situation, you would see that if I change the price, this area right here representing the change in price, we're still working with demand. And let me actually bring this just over to the demand curve. So at this price right here and corresponding quantity, if I drop the price by this amount here, this white rectangle, you'll notice that there isn't much of a response in quantity demanded. So the change in price here, this rectangle, looks larger than this rectangle here, or the change in quantity demanded. This change is greater than that change. So when we have a greater change in price than quantity demanded, we know that we are dealing with an inelastic situation. So for an elasticity coefficient greater than 1, we have an elastic curve. For an elasticity coefficient of less than 1, we have an inelastic curve. And where the change in price is equal to the change in quantity demanded, we have unitary elasticity. Oops, sorry, spelling. Okay, supply is going to work exactly the same way. A flatter supply would be a more elastic supply. A steeper supply would be a more inelastic supply. And so something to think about that you might become confused about, and I actually teach this in my other classes, is that make sure not to confuse elasticity with the slope of a line. So traditionally, when we do algebra, we look at the rise over the run. The rise being the change in y over the change in x. And that change in y over change in x corresponds to our x and y axis. Now, when we're looking at elasticity, note we are looking at the run over the rise. Because we are looking at the y-axis, actually, and I actually just did this on accident, so the run over the rise, where we have on our y-axis, we have price, and our x-axis, we have quantity. So we're looking at the change in quantity given a change in price. That would be the x-axis over y. Okay, so this is not the slope, and it's not going to be the same as your typical y equals mx plus b analysis that you do in algebra class, because they're flipped. We always think the slope is a larger number when it's steeper, right? We would say this line is steeper, so the slope is going to be larger, but it's the opposite. Our elasticity is going to be smaller when we have a more inelastic curve, and our elasticity is going to be a larger coefficient when we have a flatter or more elastic curve. Okay, so the last thing I want to talk about is practical applications of this analysis. So, sorry, just checking the time here. One practical application is to analyze revenues for the firm. So revenues, will use the demand curve to do this, and revenues are measured by the total revenue equals price times quantity. And we have this information in our graph. So in an elastic demand situation, a firm cannot raise prices and increase total revenues. They should decrease prices to increase total revenues. Why is this? For an elastic curve, the percentage change in quantity demanded is always going to be greater than the percentage change in price. Therefore, if we raise prices slightly, okay. So if we were to raise prices just slightly, our quantity would fall substantially. And if our quantity falls substantially, we will lower our total revenue. Likewise, if we have an elastic firm, we can we can lower prices just slightly, and we'll see a dramatic increase in quantity demanded. This will result in higher total revenues. And the reason being that this small increase in price leads to a large decrease in quantity. A large decrease in quantity times a small increase in price will obviously, this drastic decrease in quantity will overtake the increase in price gains that we have and will result in a lower total revenue. Sorry, my computer is slow today. If we have a little bit of a price drop and we see a large increase in quantity, this large increase in quantity will make up for the lower price that we're charging, and that will result in higher total revenues. If we have an inelastic curve, the firm should raise prices to increase total revenues. Okay, so increasing prices will actually lead to higher total revenues for a firm that is in an inelastic demand situation. Likewise, if they decrease prices, this will actually lower their total revenues. And lastly, firms can also pass some costs on to consumers. So how does this work? Why would costs need to be passed on to consumers? So the example we're going to look at deals with shifting the supply curve. So we know that the supply curve can shift for a couple of reasons. And the reasons we're going to talk about are an increase in taxes or an increase in production or input costs. So when the production or input costs or taxes change, this can shift the supply curve. If we have higher taxes, the supply curve will shift from S1 to S2. If we have higher input costs, the supply curve will shift from S1 to S2. So let's say we're manufacturing cigarettes and tax is put on the cigarettes at the manufacturer's level. This will shift our supply curve from S1 to S2 as it shifts up and to the left along an elastic demand curve. We see something happen that's very different than what happens along the elastic demand curve. So along the elastic demand curve, we see that, yes, we definitely have, or along the inelastic demand curve, we see that, yes, we definitely have a decrease in quantity demanded, but we also have a dramatic increase in price. Along the elastic demand curve, or the more flat elastic demand curve, or the more flat demand curve, we see that there is much more of a decrease in quantity demanded and a smaller increase in price that's passed on to consumers. So let's look at this a little more closely. So our original quantity supplied and demanded along an inelastic demand curve would be this price here and that quantity demanded. If the tax was placed on the cigarettes at the supplier's level, so the producer is having to pay this tax, the new equilibrium price and quantity demanded would be illustrated by the new lines I'm drawing here. And I think I'll actually change the color on them for you. We'll change this new color to purple. Okay, so we see we have an increase in price and a decrease in quantity demanded. We see that the increase in price is pretty substantial and it appears to be somewhat larger than the decrease in quantity demanded that occurs. This shows that the producer is passing more of the impact onto the consumer than they would in an elastic situation. So let's look at the elastic situation. And remember that an elastic curve is a curve where there is a small change in price and a rather large decrease in quantity demanded. So if the market were, for example, elastic, consumers would just substitute away from the purchase of cigarettes into purchasing something else. What we do find, unfortunately, is that cigarette consumption is a rather inelastic market. So our inelastic curve would actually represent what would happen. Our elastic curve could be more of a hypothetical example, but it's just looking at the fact that there are different possible responses to an increase in tax depending on what the elasticity of demand looks like for the firm. So here we see that when we have a very elastic demand for a product, which means that given a small percentage change in price, the quantity demanded will be dramatically less. People will just not buy the product anymore. That increase in price is not as large when the tax is placed on those cigarettes, the same amount of tax in both situations. And there is much less demanded and supplied in the market. However, if we have a more inelastic situation, our original quantity demanded and supplied and the corresponding price, we see much more of an increase in price than a decrease in quantity demanded than we did for this elastic curve, and the distance between the aqua line and this black line right here representing the decrease in quantity demanded. So if a product corresponds to an inelastic demand curve, okay, so if we have a more inelastic demand curve, as represented by this line here, then we would see that the firm is able to pass on more of the costs of the increase in production costs or the taxes put on their product from the supply side onto the consumer, because the consumer is not going to substitute away from their product into something else. They're still going to consume a lot of it. If we have a more elastic situation, we'll notice that here at our original equilibrium, the consumer is going to actually demand much less of the good or service, as represented by this distance being less than this distance, so the quantity demanded falls dramatically, and we don't see as much of an increase in price as represented by an elastic demand curve having this smaller increase in price over an inelastic demand curve having this larger increase in price. Therefore, in a more inelastic situation where the demand for the product is rather inelastic, consumer will consume the same amount at almost any price. The firm is able to pass more of the costs of the increase in input costs or taxes onto the consumer in the form of higher prices versus an elastic demand curve situation. So those two impacts are very important. We want to know a little bit about elasticity to understand whether the firm can increase prices and earn more revenue. They cannot in an elastic situation. They should actually lower prices to increase total revenue. In an inelastic situation, they should raise prices to increase total revenue. And if their costs increase, if the firm's costs increase and we see the supply curve shifting, either through increases in taxes or increases in production or input costs, the firm is able to pass more of these higher prices on to the consumer if their demand for the product is rather inelastic or a steep curve. An inelastic curve being a curve that has an elasticity less than 1. So the coefficient of elasticity of demand will be less than 1. If it's an elastic demand, this means that as prices increase, the consumer is just going to substitute away from the good or service into something else. And so the elasticity of demand coefficient is 1 here. So I hope everybody was able to follow most of this. It is quite confusing, so do contact me with any questions or concerns, and I wish you all the best week. Make sure to have this formula in your notes. It is highly important, and I would also be able to understand our different types of curves, elastic, inelastic, and unitary elastic, and their corresponding coefficients for the exam. Take care and talk to you guys soon.